So let's try to understand like how we can discretize these two axes here. So for example, this is like another function f, and y is the range, t is the domain here. Now the first step, which was sampling, that was as I said, quantization of this axis. So what we do is, instead of having these continuous values, we pick certain values. So, and the value should be like, maybe we divide it based on some interval. So these values T1, T2, T3, T4, these are the discrete values which will act as range for this function. And converting the continuous space to these values, that's called sampling. What it means is, this function then is only defined at these points. All right, you can't define that function between T1 and T2. Okay. Similarly, you can discretize the y-axis, which is the range of this function. And in this case, what will happen is, if you think about, of course, this function will be continuous, right? If it's like some equation which can be differentiables, it will be continuous function. So what will happen is, if you use the value of T1, it will give you some value of y, let's say at this location. Similarly, T2 and T3, you get these values. Now, what you do is, you say that we are not going to use all the values in this y-axis. We are only going to use some certain values. And what's going to happen is, the values which this function is returning, we are going to round them off. And this rounding is called actually discretization. Okay. So that was a single like one-dimensional function. We can generalize that to two-dimensional function as well. And your images are two-dimensional function. And in this case, what's going to happen is, you will discretize not just one axis, you will discretize both x and y axis, because it's a two-dimensional function. Okay, but it's the same process, but you have to perform on all the on both the axes. And similarly, like your range is always going to be like a single axis. Y, this vertical axis in this case, the process remains the same here. And if you try to represent that as like a matrix over here, what this means is, you are dividing that continuous space into this kind of grid. Okay, so in this grid, your x-axis and y-axis, they will have only discrete values. Let's say 1, 2, 3, 4 all the way up to m, and 1, 2, 3, 4 all the way up to n. So these cells here becomes range of your function, and whatever value these pixels can actually have, they define the range of this function f. And again, we will have to discretize those values as well to complete the second step of digitization. And of course, we can extend that to 3D function as well. The only change here will be like, instead of 2 axes, we'll have 3 axes here, and you will have to discretize all those 3 axes. Now let's try to understand both the steps using digitization of this arc over here. So let's say we have this arc in this 2D space. All right. Now what we do is, so this actual arc is actually very continuous, right? So what we do is, we create like this kind of grid where we have these steps in x-axis and let's say in the y-axis, and we can only have values at these cells, at the center, wherever like these axes are crossing. Okay, so the continuous curve was the original curve, but these blocks which I'm showing, this is the discretized version. Okay, and you can note here that like we are only assigning values when these axes are crossing. Okay, and if you just omit like this continuous curve, that you can still see like the digitized version. So that was sampling. Now coming to the second step, which is like quantization, what we do is, we can only have, let's say, 2 values, 0 and 1. So all these like white spaces over here, all these have 0, right? Which means like the arc is not present. And wherever it's gray, that just say that, okay, arc is present. So we just store 2 values. But this arc might have like more than 2 values, right? Because it will the full range from 0 to 256. So that was an arc. This is actually showing a real grayscale image. And if you try to understand this, this axis and this axis is actually the grid, which is forming the image. And this is giving like the resolution of the image. In this case, it's 150 cross 150, which means like this image has 150 times 150 pixels. And this vertical axis over here is just showing you the intensity at each pixel. And again, this is kind of discrete because we can say that, okay, exactly like which grid cell in this range has like actually what value. And again, that value will be discrete. It will be coming from the range over here.